So we're going to be looking at the trigonometry today, the start of it. Trigonometry, if you look at the kind of root of the word right here, tri is for triangle and metry is measure. So we're kind of studying triangles, and specifically we're going to be looking at right triangles today, triangles that have a 90-degree angle in them. Trigonometry as an entire subject is pretty useful, and it has a lot of applications in various things. We actually use it in one way to model periodic functions, so things that happen like repeatedly. If you think about like a heart monitor, how it goes like beep, 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 that kind of wave function too, that repeated periodic motion, something like sound waves and light waves. All these things can be modeled with trigonometric functions, so these functions kind of based around again, the study of a triangle. Also allows us to, people used it in astronomy to kind of measure distances that were like really far away, or maybe even like kind of things that were impossible just to measure or tell normally. It was used in navigation a lot when people were sailing, and we'll be using it more specifically to try to determine heights and distances, but these later applications will be especially used in algebra too. So again, trigonometry, study of triangles. Just really quickly, we have these things called sine, not sin, but sine, cosine, and tangent. And the S for sine is in this mnemonic called SOHCAHTOA, which we'll talk about in a little bit. The C stands for the cosine, and T stands for tangent. And what these things are, sine, cosine, and tangent, they are a ratio, but basically another way to think about it is it's a relationship of the sides of a triangle in relation to a particular angle. So just really briefly, when we look at trigonometry, there is something later on that you'll study, which is the unit circle. That's the one where you have a radius of 1, the hypotenuse. Kind of drop this guy down, and we get a right triangle. So our definition of these things comes from the study of a triangle going around the unit circle. We call this length, the height of that triangle, sine. So sine is basically the y, or the height of your triangle. And then we say that the length here of that triangle is called cosine. And so it's just a name, sine and cosine, but it's a relationship between two sides for this particular angle of a right triangle. Specifically, it's going to be the opposite over the hypotenuse, which we'll see in a little bit. So it's just, again, this thing, the y value, the height for a particular point. And the cosine is going to be the x value. So if we're looking at a particular point on this unit circle, say a point like right there from the triangle, the xy value would be given by the cosine, and the y value would be the sine value for that particular angle. That's something we'll explore in later math classes, but for now it's kind of the little intro for it. You can see an animation going here, and so this gets at the periodic nature, this kind of repeated motion for, in this case, the sine function. And you'll notice over here that blue line, that blue dashed line, that's the height of the triangle. And so it kind of goes up and it goes down, it gets bigger and then it gets smaller as you are a point on this line. But again, you can see a right triangle being formed, this cyclical, what we call periodic motion. If I switch it to then cosine, that cosine then is defined as that length, that x value, how much you've gone left or right. And tangent's a relationship between sine and cosine. So given any, we'll say, right triangle in which A is one of the angles. Oops, when A is one of the, acute angles. So acute being less than 90 degrees. So the 90 degrees is going to be bigger because a triangle has 180 degrees to it. So if 90 is already used up, that leaves you with just 90 degrees left for two angles. So these are going to be acute or smaller than 90 degrees. So the sine, this relationship, is SOHCAHTOA. Sine is going to be equal. So sine of A is going to be equal to the opposite side, O for opposite, and HYP stands for the hypotenuse of your triangle, the longest side. The so sine is equal to opposite over hypotenuse. Cosine is going to be equal to what's called the adjacent side over the hypotenuse. That's its relationship, its ratio. And the tangent, TOA, is going to be equal to the opposite side over the adjacent side. So if I'm looking at sine of A, cosine of A, tangent of A. So I'm looking at this angle here, angle A, and I want to relate some sides of the triangle. Now, opposite the 90 degrees, so opposite the 90, the longest side, the hypotenuse, is always opposite the 90 degree. So this side always stays the same no matter where you are. If you're talking about angle B, if you're talking about angle A, the hypotenuse is still the same. The adjacent side is the side that's right next to the angle. So if I'm talking about angle A, the side that's right next to it, that's not the hypotenuse, is the adjacent side. So adjacent, which we abbreviate ADJ, means next to. And it's the side that you actually touch with the angle. That kind of leaves one side left over, and that's the opposite side. So the opposite side from angle A is going to be the one that you go across the way from that's not the hypotenuse. So adjacent's next to, opposite, you kind of have to go across the figure, and the hypotenuse is the longest side, always opposite the 90-degree angle. It's always that longest side. Okay. When we're labeling these things as well, this side gets labeled as a little a, this side gets labeled as a little c, and this side gets labeled as a little b. So when we're talking about angle A, angle B, angle C, side A is the one that's opposite here, side B is opposite from this angle, and side C is opposite the hypotenuse, that little c right there. Okay. So if I were to actually calculate this, what is the sine of angle A? So sine is SOHCAHTOA, SOHCAHTOA. So you write this down so you can remember it. Sine is opposite over hypotenuse. So sine of an angle, well, I'm doing the angle A. So opposite, which is A, over the hypotenuse, which is length, little c. Cosine, so SOHCAHTOA, the cosine is adjacent over hypotenuse. So cosine of this angle A is going to be equal to the adjacent side, which is B, over the hypotenuse, which is C. And then the last one, TOA, SOHCAHTOA, the T stands for the tangent. So tangent of this angle A, this relationship, this special relationship called tangent, it's going to be equal to the opposite side. So my opposite side, A, over the adjacent side, which is B. So we have these special relationships, and kind of what I showed you a little bit before, the sine, when we're talking about these things, refers to the height of your triangle, typically, and then the cosine is going to be like that length of the x value, but that's a little bit later on. Okay. Something to point out is that the opposite side and the adjacent side aren't going to be the same for every angle. For example, if we had been looking at or calculating the sine of angle B, so now I'm just looking at, instead of angle A, if I focus on angle B right here, so if I want to know the sine of angle B, that relationship, well, again, hypotenuse is always the same. It's opposite the 90. Adjacent is a side that touches the angle that isn't the hypotenuse, so it's right next to angle B. It's the adjacent side. That leaves this side now being the opposite side. So sine, katoa, so opposite over the hypotenuse. Now that would be, if I label these again, little a, little b, little c, the opposite side is b, and the hypotenuse is c. So again, that's different from what the sine of angle A was. Sine of angle A was opposite over hypotenuse, that was a over c, but that's going to be different than for angle B. That's a different relationship of sides. That's going to be b over c, or opposite over hypotenuse there. Okay, so it does change. All right, so moving on. This is refer to triangle EFG. Give each trig ratio in terms of f, g, and e. So little f, little g, and little e. So I'm going to label my sides. Opposite the e, the big E, is little e. Opposite the big G is little g. And opposite f, big F, is little f. And again, I can kind of label my hypotenuse right away as well. Opposite the 90 side, the longest side, is the hypotenuse. So this side's automatically going to be the hypotenuse. And it looks like I've got sine of f, tangent of f, and then I need to be careful with this last one. It's sine of angle G. So for starters, though, we're going to be looking at angle f. And I'm going to be using my SOHCAHTOA to help me out. So I'll write it down again. SOHCAHTOA. So sine, S, sine, its relationship is with the opposite side over the hypotenuse. So since I'm doing sine of angle F, I go to angle F, and I want to know the opposite side. That's going to be little f, over the hypotenuse, which is E. So for this first one, opposite over hypotenuse, the opposite to angle F is little f, and the hypotenuse is E. So f over E. The cosine of f, SOHCAHTOA, the adjacent side, so the side right next to it that isn't the hypotenuse, so this is your adjacent side. That means that this side's the opposite. So SOHCAH, so A for adjacent, H is the hypotenuse. Cosine of f is going to be G over E. And then tangent, TOA, opposite over adjacent. That's going to be f over G. Okay. And then sine of G, I need to be careful because these sides are going to change again. So sine of G now, angle F, the adjacent side is now this side, and the opposite side is now this side. So sine, again, SOHCAHTOA, so opposite over the hypotenuse. And then the opposite side for angle G is G. And the hypotenuse is E. Okay. So we can find particular, use these relationships to say, find particular angle measures. So for instance, what this one is trying to kind of find out, let's say sine of 30 degrees. So if I had a triangle and I try to make, if this is 90 degrees, halfway would be 45 degrees. So I'm trying to make a triangle where the angle is about 30 degrees. So somewhere around here would be 30 degrees. I want to know what the sine is. Well, sine, we kind of remember, is that y value. So I want to know what would be the y value for a triangle that has 30 degrees. So that opposite side, the opposite of our hypotenuse, but remember the hypotenuse is 1. Well, there's ways we can there's certain values that we memorize that you'll do in Mr. Lewis's class or Miss Carruthers' class. But for now, sine of 30 degrees, we're going to use Desmos to calculate. So I'm going to go to Desmos. And one thing I have to make sure is that you are in degree mode, whether or not you use a TI-83 or TI-30 or Desmos. So I'm going to click this gear icon, and right here I can switch between radians and degrees. I want to be in degree mode, and I'm going to type my question in. So sine of 30 degrees, that's not 30, sine of 30 is equal to 0.5. So pretty simple. Sine of 30 degrees is equal to 0.5. So if this highest value is 1, it goes, here's -1 and 1 for the unit circle. That's 1 is the highest value. That means the 30 degrees is going right about there. It's about halfway. It is halfway. It's 0.5. Okay. And then we're just going to use the calculator to do these other values. Cosine of 60 degrees, so I'm going to go back to Desmos, type in cosine of 60, and I get 0.5 as well. And again, what this is symbolically asking is that if you had a unit circle, so 1, -1, 1, -1, and 60 degrees. So again, here's 45, so here's 90, so 60 degrees is somewhere maybe right about here. So if you were to drop this down and make your triangle, then the cosine, which is the adjacent side over the hypotenuse, so it's asking for what's the length of this side, the x value, it would be 0.5 or halfway. Come on, eraser. All right. Okay, cosine of 48 degrees. That one definitely couldn't figure out just off the top of my head, more than likely. So cosine of 48 is, we'll round it, 0.67. Tangent is 70. TAN does not need to be in all caps. Actually, should not be in all caps. Tan of 70 is 2.7. We'll round it to 2.75. And again, make sure you're in degree mode. Yep, 2.75. All right. Again, these are just relationships of sides of a triangle. So they have some special meaning for like sine and cosine. Tangent does have a special meaning as well, which we'll eventually get into. All right. The next section is going to be kind of how do you go backwards. So given an angle, can you tell me the kind of x or y value? This is, you already have that value. Can you go backwards and then figure out what the angle was? And so what we're going to do is actually do the inverse functions, or the opposite functions of these two things, of the sine function, the inverse of the cosine, the inverse of the tangent, to get these values. And again, we're going to have to use the calculator. Some of these things you could do by setting up by hand, but we're going to use the calculator. So what I'm actually going to do is I'm going to do the special function called the inverse function. Now it looks like sine to the -1, but that's actually a special symbol for this trigonometric functions. It's called the inverse. So this is the inverse of sine. So I'm going to take the inverse on both sides. And when I do the inverse, that cancels those things out. So the inverse of sine, that's opposite, cancels it out, leaving me with just this angle A is equal to the inverse sine of 0.3991. So I'm going to go to my calculator. I'm going to see, probably should, if I pull up the keyboard, go to functions, you see they have these little functions right here, the inverse sine. So I wanted inverse sine of 0.3991. And that tells me that that would be equivalent to have that relationship, those sides, the opposite side divided by the hypotenuse, whatever it is, if it was like 4 divided by 7 or something like that. Essentially what's going to happen is that to get that ratio, it must have been about a 23.52 degree angle. So a 23.52 degrees. That's what angle A must have been to get this type of relationship with sine. So I'm given this relationship, the cosine, which was the adjacent side, so toa, the adjacent side over the hypotenuse. To get this value, I must have had a very particular angle B. And so if I can know those two lengths, I can say what the angle must be. So for instance, let's say you had like a building and you had a ladder. This is a type of problem we'll kind of do later. You can say, well, I need to get to this window. I need to get to this height. Well, if you have, say, maybe like a certain ratio, you can say, okay, what angle do I need to put this thing at so that I can get to put the ladder up here and have it be that length, or the proper placing. We'll look at some of those later. So anyway, cosine of B. So I'm going to do the inverse on both sides. So the inverse of cosine of B, what I do to one side, I do to the other. So these cancel each other out, leaving me with angle B. And then cosine of 0.4, that's easy, 4567. So functions, inverse cosine of 0.4567. Must have been a 62.83 degree angle. So 62.83. All right, so we'll do these other ones. Inverse tangent. So F is going to equal to the inverse tangent of 7/4. And F is going to equal here the inverse sine of 8/5. Okay. And I think one of these is going to be special. We'll see. So inverse tangent of 7/4. Inverse tangent of 7/4 is 62.26 degrees. And then inverse sine of 8/5. Inverse sine of 8/5. And we get this thing that says undefined. Okay. Well, let's think about this for 1 second. Sine, that relationship, is the opposite over the hypotenuse. The hypotenuse is the longest side of your triangle. So there's no way that you could have an opposite side of 8 and have a hypotenuse of 5. There's no triangle that would actually have that. So that's why it's undefined. This one is not possible. There's no angle or degree that would ever make this thing true. So this is undefined. All right. These are just kind of solving equations. To get rid of, solve for x, we need x to be in the numerator and for it to be by itself. So I'm going to get rid of x in the bottom. I'm going to multiply by x on both sides. That cancels. So I have x times the sine of 65 degrees equals 12. Again, sine of 65 degrees is just going to be a number. It's a relationship. So a 65-degree angle must have had a particular ratio of its opposite over its hypotenuse. It's a known value. I can plug it into the calculator. So x would equal 12. I would divide both sides of sine of 65. I'll write it out step by step. So divide both sides by sine of 65, sine of 65. These cancel. Anything over itself is 1. You get x equals, and 12 divided by sine of 65. Gets you 13.24. So that opposite over hypotenuse, your hypotenuse must have been 13.24 inches or whatever that is. This one, x is already in the top, so I can just multiply both sides by 5. Cancels. X equals 5 times the cosine of 71. You can plug that into the calculator and do that one. This one, same idea. Multiply both sides by 15. Cancels. X is going to equal 15 times the tangent of 33 degrees. This one, to get that angle by itself, I have to do the inverse. So to get rid of this equation sign, or this function sign, I have to do the inverse of that sine function. So I'm going to take the inverse on both sides to break that apart. And so the inverse and the sine function cancel each other out. So x is going to be equal to, and again, I would do inverse sine of 23 over 45, which gets you 30.74. So that must have been a 30.74 degree angle to give you that type of opposite length and hypotenuse. All right, and last two, again, solve for x. Multiply both sides by x. That cancels. X times cosine of 48 degrees equals 17. Divide both sides by cosine of 48. Plug it in on the calculator and get your answer. You're solving for the angle, so to get the angle by itself, you have to undo the function. So opposite of tangent is the inverse tangent. Cancels. X equals the inverse tangent of 17 over 24. So inverse tangent of 17 over 24 would be a 35.31 degree angle. What this is kind of doing is going a little bit backwards, but if you think about, say, you have a triangle, an angle. You know tangent, TOA, SOHCAHTOA, the opposite over the adjacent. So the opposite side must have been 17, and the adjacent side is 24, and then you're basically kind of trying to use that relationship of known values to figure out what this angle must have been. All right. So these ones you can plug in on the calculator. I'll leave it just kind of as an exercise. It's not too big of a deal. But again, trigonometry, we're looking specifically at right triangle trig. So trig where you have a right angle. There are other types of trig that we'll look at too that don't involve right triangles, but for now we're looking at that special case where you always have a right triangle. When you do have a right triangle, you get this relationship called SOHCAHTOA, where sine represents the opposite over the hypotenuse side, cosine of an angle is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. There are more relationships, but those are the main ones that we look at. If you kind of go back here, we have sine, cosine, tangent. There's something called cosecant. secant, and cotangent as well. Also, there are hyperbolic trigonometric functions, which is when you get into geometries where there are no longer like flat planes, like curved geometries. So like if you were doing a globe, if you had a triangle, you drew a triangle on a globe, what would that look like? How would that work? That would be these types of functions. All right, so that is your intro to